everybody. Today we are trying something new. I'm recording my lecture so that you can watch it while I'm gone today, so I hope you like it. If you were here in class yesterday, then you've already seen the beginning part of this lecture. You can go ahead and skip ahead to the part where the material seems new to you, or feel free to listen to the beginning part again just in case you want a refresher. So here we are, picking up where we left off in section 2.2, linear functions, part 2, writing equations of lines. Our learning goals for this section, it's basically to do everything that we can do with lines given any sort of information. So recognize standard point slope and slope intercept forms of linear equations. You can already do that. If you remember, you can look back at your notes at that list of equations that we wrote at the beginning of this section as a refresher. Write the equation of a line given a point and its slope. Write the equation of a line given 2 points. Given a line and a point, write the equation of the lines parallel and perpendicular to that line. I think the only real new piece of information here will be the parallel and perpendicular equations. But you may have heard of these things before. If you have, try to think about right now what is the difference or what is similar about one line and the line parallel to that line and the line perpendicular to that line. If you're thinking it has something to do with the slope, then you would be accurate. And so try to write that down, see if you can get that right when we come to that material later on in this lecture. Here's the scale for today. I hope no one is at a 0. I have no idea what the equation of the line is or what it looks like. And our goal is going to be to get to a 3 by the end of this section. I can recognize the different forms of a linear equation, which most of you can already do, solve for them, and find parallel and perpendicular lines. So the second two pieces of this goal, the solve for them, find parallel and perpendicular, those may be relatively new for you. They may be relatively easy. By solving for them, I mean given any sort of combination of information, whether it's 2 points, a point and a slope, or something else, can you find the equation of a line in any sort of form? And then, of course, parallel and perpendicular may be the newest pieces of information for you. All right, so we've already gone over standard form and slope-intercept form. By now, I hope they're getting a little bit more familiar to you, especially slope-intercept would be the most familiar to everybody. And standard form is also something that I want you to get used to. Remember that we talked about how it's useful so that you can use standard form to solve for the x and y intercepts respectively. Then we'll go over that a little bit more later on in this section. But the third one that we haven't talked about so much yet is the point slope form. And really it's often the hardest one to memorize. This one here is y minus y1 equals mx minus x1. Now, two important pieces of information here. First of all, notice that none of these values represents the y-intercept. It's unlike slope-intercept form in that regard. Second of all, x1 and y1 represent the coordinates of a point, as it shows you in the orange box here. X and y, as you see them, are going to stay in the equation. What I find from a lot of students is that when they're solving for point slope form, or any forms that we're going to get to, is that they'll substitute numbers for all of the values that you see in front of you, which is incorrect. When we write the equation of a line, we always have an x and a y in it. Otherwise, it wouldn't make sense. For example, if I said to you, okay, graph the line 4 equals 3 times 1 plus 1. That wouldn't make sense. You'd be graphing something that ended up being 4 equals 4. That doesn't make sense. How can you graph that? It's not a line. So we would expect that the equation of a line has an x value and a y value in it. So if I said to you, graph the line y equals 3x plus 1, that makes a lot more sense. You could do that. Similarly, when we have point slope form, as you see in front of you, We'll plug in values for y1, m, and x1, but never for x and y here and here for our final answer. Here's our first example. This one says write in standard form of an equation of a form of equation of the line with the slope -1/2 through the point 8, -1. All right, first thing to notice about this question is that they're asking us for standard form, but they're giving us a slope and a point. They're kind of telling us which form that we have to use first. We know that our answer will be in standard form, but they're giving us a slope and a point. So we're almost forced to use point slope form. Now, some of you may be familiar with how to solve this question with slope intercept form, which is something that you can do. If you're not familiar with that method, then point slope form is the way to go here. So the very first thing we're going to do is plug in these values 8, -1, and -1/2 into point slope form. I also want to point out that we cannot go straight into standard form as the question is asking us to do. And that's because these values, as you see them, 8, -1, and -1/2, do not correspond to A, B, and C in standard form. Instead, we're going to put them straight into the point slope formula, where this over here, slope, it represents M, 8 represents x1, and -1 represents y1. So the first step here shows us the formula for point slope, and then secondly, you can input your values, blue, pink, and green. Now over here, we can simplify quite easily. Oh, and then they distribute. They distribute this -1/2 to the x and the 8, and we can kind of simplify the negatives more easily if we did that first. But sure, why not? The book likes to do this way. Over here on the left-hand side, we have the negative times the negative will give us +1. -1/2 times x remains -1/2 x. And then -1/2 times 8 will give us -4. Minus -4 will eventually simplify. So now our simplified version, y plus 1 equals -1/2 x plus 4. In order to get this into standard form, however, we'll need to eventually get the x and the y on the same side, because if you remember standard form, it's ax plus by equals c. And we'll notice that the x and the y are on the same side. So the first thing we'll do is move this -1/2 x over to the left-hand side, and then next we'll move this 1 over to the right-hand side. When we move the x, it will become positive. When we move the 1, we'll have 4 minus 1 to give us 3, and now we're in standard form. I want you to try examples A and B on your own. Feel free to pause the video, give them a try, and then I'll show you the answers on the next slide. All right, here are the answers. Number 1, the answer was D. 2, the answer was A. If you didn't get them correct, pause it, give them a look, and maybe ask another student for help if you need it. All right, so for those of you who were in class yesterday, this is where you should be picking up since we didn't get to example 5 just yet. In example 5, they're asking us to write an equation in point slope form given 2 points. Now this is a problem for us initially because we know in point slope form the name says we need both a point and a slope. And they're just giving us 2 points here. Well, we can use either one of the points eventually, but we're also going to have to find the slope. Now you should remember from previous lessons, the way we find slope is slope formula. Try to remember what that formula is and write it down before I show it to you now. Here's point slope equation. The first thing we're going to do is use slope formula, which is y2 minus y1 over x2 minus x1. We'll plug in these values here, 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 and here into slope formula. When we do, you should get something like 5 minus -1 to give us 6 on the numerator, over 1 minus 4 to give us negative 3 on the denominator. 6 over negative 3 will reduce to give us negative 2 as our slope. Once we have our slope, we're almost there. All we have to do now is choose either this point here or this point here and plug it in where we see x1 and y1 in the equation. So, the book is showing us here as m is substituted for negative 6 over 3, which we know already reduces to negative 2 as we solved for already. They also plugged in 5 and 1 from this point here into the formula. Now they could have chosen this one or 4 negative 1. Either way would give you the correct answer. So we get in simplified form y minus 5 equals negative 2 x minus 1. If you're thinking this isn't solved for just yet because y still has that minus 5, you would be thinking that we need to put this into slope-intercept form when the question has already asked us for point slope. So really we're done, but had the question asked us for slope-intercept, you could easily solve for that by simplifying here on the right by distributing and then adding 5 to both sides. But since they asked for point slope, we're done. This problem is pretty easy. All right, I want you to try A, B, and C on your own. Pause the video, give them a try, and I'll show you the answers on the next slide. All right, here come the answers. Number 1, the answer was B, y minus 0 equals negative 1/4 x minus 5. Now a lot of students here ask, do we really have to write the minus 0? And the answer is pretty much no, but if we're going to be very formal in the way we write point slope form, then technically sure we'll give them the y minus 0 just to be kind of extra specific here. But you and I both understand that subtracting nothing means we don't really have to write it. Number 2, the answer was C. Y plus 1 equals negative 9/4 x plus 2. Notice that we're simplifying here and here. If we had negative 2 and negative 1, minus and negative becomes a positive, and so we will want to represent that accurately. All right, the last thing that the book is going to review with you is slope-intercept form, which we already know. In slope-intercept form, we have y equals mx plus b. And here we go with our final example for this lesson. Find the slope, and we're given standard form. Now there are 2 ways of doing this. First of all, we can take this standard form and solve for y, thereby turning it into slope-intercept form. There's also a formula that we can use anytime that we want to do this problem quite easily, and that's to take our a value, turn it into a negative, and divide by our b value. So for example, a shortcut to this problem is negative 4 over 3. But if we wanted to check our answer, we could easily solve for y. The first thing we'll do is subtract 4x from both sides, and then we'll divide by 3. When we do, notice that we have to divide both terms by 3. So not only this term in front of x, the coefficient, but also this value here, both of which will be divided by 3. Now we've written the equation in slope-intercept form. We have the slope, negative 4/3. But again, you can use the shortcut, which is that the slope from standard form is negative a over b. All right, go ahead and try A, B, and C on your own. I'll show you the answers on the next slide. All right, number 1, the answer was C, negative 3/2. Number 2, the answer was A, negative 4/3. And number 3, the answer was B, negative a over b, our formula.